recognition has become a very important part of eyewitness testimony because we rely on being able to recognize faces to select someone that we believe to be a criminal in some sort of investigation. So thus far from previous research, we know that actually being able to accurately identify faces is very difficult. We're not particularly great at remembering the faces that we've seen previously. It's even more so a problem when we are looking at faces of another race. This is called the own race bias, and it is an unconscious bias that just simply means that we are a lot better at perceiving and remembering the faces of our own race as compared to other race faces. And this is believed to be largely due to attention and face-based frameworks. They simply mean that when you are looking at someone of your own race, you become accustomed to perceiving those individuating facial features more so than another race. So for example, Caucasian faces vary more in upper facial features. So things like eye shape, eye color, hair color, and structure are more memorable because you become accustomed to looking at it. Whereas in other races, their faces differentiate more in the lower facial features, so nose, lips, and jaw structure. So thus far, actual rates of eyewitness error are unknown because unless some sort of physical evidence comes up later on, it can't be overturned. But we do know that in North America and Great Britain, faulty eyewitness testimony leads to more wrongly convicted people than any other factor. A study in 2004 also showed us that of 8,000 arrests for sexual assault, 2,000 were later excluded by DNA evidence. When we consider that a quarter of cases can be overturned at a later time because physical evidence does occur, we're looking at a very large problem. Especially if we consider cases that are very high stakes and may even involve a potential death penalty. If a quarter of these cases can later be overturned due to faulty eyewitness testimony, that's a very big problem. In one of my own current studies, we are looking at attentional issues of facial recognition. So we put our participants in one of two conditions, either full attention, where they strictly stare at a face for approximately 6 seconds, or we do divided attention, where they have to look at a math problem, answer the math problem, and also look at the face at the same time. We then quiz them and see what faces they remember actually having seen previously. And we then record their percentages of correct recognition and correct rejection. And thus far, we have found that when someone is in the full attention condition, which is the graph on the far left here, they can remember the face accurately about 75% of the time. However, when their attention is divided, they accurately remember the face a little over 50% of the time. And if you are to actually witness a crime, chances are you're looking at the entire scene. You're not simply focusing on a person's face the entire time. There's many other things to take in, and your attention is absolutely divided. And if we only have a 50-50 chance of actually remembering that face accurately and being able to testify to that later on, that's a pretty big problem to have. So let's do a little experiment. 2 slides ago, I had a face displayed. So just by a show of hands, if you think it's the one on the far left, the middle, or the far right. Yeah, when it's amplified and right in your face, it's a lot easier to see it and to remember it later on than if you were to actually be a witness to a crime and to see it perhaps from a distance or not even know what's happening as you're watching it. So our results did show a significant reduction in our ability to accurately remember faces between our full and divided attention conditions. So by doing this kind of research, we're hoping to bring a little bit more information to the public and to hopefully influence policy later on that places such an importance on eyewitness testimony when it is clearly unreliable. Thank you.